All right, we're just going to take a look at the first three problems on the equilibrium practice problem worksheet. Just going to talk you through what I did to get each one. So number one reads that the object below lies motionless on the floor. We're going to find the normal force acting on the object. So here's my picture. I've got the normal force going up. I've got force of gravity going down. The mass is written 7 kilograms. My equation is over here. How did I get this? My up arrows, which is my normal force, is positive. My down arrows, which is gravity, is minus. And once I'm done with my up arrows minus my down arrows, I get that all equal to 0. So I'm trying to solve for the normal force. I'm going to move force of gravity to the other side. I do that by adding it, which gives me normal force equals force of gravity. And I know the force of gravity is equal to mass times 9.8, or mg. That's on your equation sheet. So I can just plug in the numbers. Normal force equals the mass, which is 7, times g, which is 9.8 meters per second squared, giving me my answer, which is a normal force equals 68.6 newtons. Moving on to number 2. This object is moving at a constant speed to the right, I believe, and we're still trying to find the normal force. Just because it's moving to the right or to the left does not mean there's a force acting on it. Think if you go bowling. Once you've already rolled the ball, it continues to move even though you're not pushing it. So the normal force is up, and that's our question mark. Force of gravity is down. This equation is set up the same as the previous one. My up arrow, normal, minus my down arrow, gravity, equals 0. So normal equals force of gravity, my second line here. And I know force of gravity is mass times g, which is 9.8. So I can plug in my numbers in the next line. Mass is 5 kilograms. G is 9.8 meters per second squared. And my calculator gives me 49 newtons. Moving down to number 3. Object below is being pushed to the right with a force of 20 newtons. That is in our picture. As a result of the push, the object is moving at a constant speed. We're going to find the normal force. And then we're going to find the force of friction on the object. Normal force is up. Gravity is down. Force of friction to the left. Now I'm going to add up my up and down stuff. First, I could add up left and right. There's no particular order here that we have to do it. My normal force is my upward force. Gravity is my downward force. That's why it's minus gravity equals 0. Normal is going to equal gravity because my up stuff equals my down stuff. We have an equation for gravity, which is mass times g, which is 9.8. So I plug in my numbers, mass 9 kilograms, g 9.8 meters per second squared, and I get that the normal force is 88.2 newtons. Now when I go to the left and right, my right arrow is positive, which is my force of push or pull or whatever you want to call it, minus my left arrow, which is friction. Those add up to be 0. My right stuff equals my left stuff. And I know that the force of push is 20 newtons. It was given in the problem, and it's in the picture. So I can just plug in 20 newtons for force of push. So that must be what friction is.